So in this lesson, we're going to show you how to work from a glossary of useful nodes, show you the kinds of nodes that will be very common in terms of building your flows. So to get the glossary, we go to your homepage and then click the link to the pre-written nodes here. That will bring you to our pre-written nodes shared folder. Click on, and we're going to download the glossaries file, and then I'm going to import this into the flow. From my download folder, click glossaries, import copy. So now I have a glossary of useful nodes, which I'm going to deploy. The first node is the inject node, which you're familiar with. So if we click, so we use this to start a flow and to set times. If you open up the tray, you can see that you can pass things through the payload, through the topic, or you can add your own messages. So say you were doing NVIDIA. Then we have the debug node, which is used to display the contents of the flow to the debug panel. So this is set up to pass some text. So you can see it sends the message to the debug panel. Then the function node, which is this is the low-code node. So this is where we execute JavaScript commands. If I open this tray, you can see I put in a text node warn, which is our print function essentially. And when I click this, this sends the text through to the debug panel. And then the loop node, which is very useful if we're trying to say a loop through a series of time series data, and we want to have 1 minute shown after another. So we use this loop node. So if you open this up, you set how many times you want it to pass through. In this case, I set 3, so this will show 3. And then in the function node, I put in a text testing, and then I put the message loop value, which will pick up the number of the loops. So when I click this, you can see I got testing 1, 2, 3, as expected. Now we may be passing buy orders through to Alpaca, in which case we don't want to overload it. Say we're buying 100 stocks, which is certainly possible to do. We don't want to pass all 100 instantaneously because Alpaca might choke on that. So we need to put in a delay node. So that's this delay node here. I set this up to delay 2 seconds. This, by the way, can be milliseconds, seconds, minutes, hours, days, whatever you want. I put down 2 seconds. And then in the function node, we're showing the function node copy. So there was a delay of 2 seconds before it executed that command. And then the rate limit node, which is the same node actually as the delay node, but its setting is rate limit rather than delay each message. So the default setting for the delay node is the top is delay. But if you pull down the menu, you can see you get rate limit. So I'm going to demonstrate the rate limit here. So in the rate limit, this is the way we kind of limit how rapidly we're sending things to a flow. So I'm going to pass a list of an array with 3 tickers in it, SPY, NVIDIA, and Apple. And I'm going to split this array. By the way, I'm using the split node here, which is also, you'll find to be a very useful node. In this particular case, you're splitting on the message payload. I named it here, and then I can either split, you might split on a string. You could send this as a stream of messages. In this case, I'm splitting on the comma separator so that I get them one at a time. I'm going to rate limit 1 per second and send that to the debugger. So now we see each ticker is being sent 1 per second. You'll get more information about this in the next section. This is a function node that I'm going to use to set a global variable. So it's in the case of setting some keys, if you're bringing in an API, I want to set the API for the Polygon key. So I do that by saying global set, and I name it Polygon key, and then I have the key here. So when I execute this, and then I go to the context node, which will show me the various globals. And then you can see if I scroll down to Polygon key, you can see I've stored that. So that's stored. And then this HTTP request node, when we want to say get, use a get method to go get something from a website. In this case, I want to go to Polygon. I'm using this request to make a request to Polygon, and I'm passing my API key. And I'm looking for what the current market status is. So this is again, a very common node. But this is the way we find out whether the market's open. So I'm going to get the global Polygon key, retrieve here, send it as message key, and include that in the HTTP request. You can see key in this syntax. So it's basically 3 parentheses on each side of the key. And then I'm going to display it here, display. I'm also going to save that market status as an object because oftentimes I'll want to know for my nodes whether the market's open. So you can see here I've gotten information from Polygon. I'm doing this on a Sunday. The market's closed. The early hours and after hours are both closed, or both false. Similarly, we can make a request for a ticker. In this case, I'm going to send a ticker along with the key message symbol to the Polygon request. And you can see here I've gotten ticker information. This is all the detailed information from Polygon about NVIDIA, description, address, etc., etc. Now I can do something pretty similar with Alpaca. By the way, you see these nodes are color-coded. The yellow nodes are all the Alpaca nodes. So these all correspond to various endpoints in the Alpaca API. So we're going to use here the Alpaca asset query. In this case, I'm going to send the message symbol for NVIDIA. And you can see that Alpaca has provided this is its asset information, its asset detail. It's very common to be requiring the information about the last trade or the last quote. In this case, I'm passing the NVIDIA symbol to the Alpaca last trade node, and I'm getting back the information about the last trade. So the price was $124.95. You also might want to use the last quote in your flow rather than the last trade. So in that case, you'd use the Alpaca last quote node. So the last quote was 125.10, and then it tells you what time. Again, I'm doing this on a Sunday, so this was on a Friday before. Similarly, we can get information about the crypto pricing. The only catch with the crypto is, with the crypto, we have to make sure we put a slash between the initial 3 characters of the symbol. and USD at the end. This is the way Alpaca wrote its endpoint. If you don't pass the slash, you won't get a result. So remember to do that. And when I pass this, I'm going to get a price for Bitcoin. So you can see here the ticker is BTC USD. The price is $86,000.34. So that's the current price for Bitcoin. But it fall off from earlier in the year where it went past 100,000 on all the crypto enthusiasm. This next Alpaca node is the last bar. It's not unusual the difference between a bar and a trade. The bar is actually showing the opening, the close, high, low for that particular moment. So when I click on the last bar, and in this case I'm just sending the symbol to the last bar, Alpaca last bar node. And you can see I'm getting open, high, low, close, volume, number of trades. And then more useful than the last bar is actually the Alpaca range bar, where you define a range and the time this time interval for the bar. In this case, I'm going to ask for all the bars between the beginning of October 28th and the next day, which was March 1st, which is the end. I'm asking for 1 minute bars. These can also be like, this could be 1 day. It can be 1 second too. Actually, Alpaca doesn't provide 1 second, so 1 day. So these are the other options for the time intervals. And to make sure I'm getting one, I put in a print statement or a node warn for the symbol, the start, the end, and the time frame. Pass that to the last bar, or rather the range bars, and then display that. So in this case now I've gotten back 439 bars, an array with 439 bars. So this is for every bar for the 28th of February, and it's starting at 1300. And you get the open, the close for that particular minute. So this is the start of that minute. And then it proceeds to the next 439 minutes. Also useful, which is the Alpaca account query. This provides information about each of your accounts. In this case, I'm looking at the paper account rather than the live account, and I send this to the debugger. So this tells me how much I have in a lot of details actually about the account. And I could also have gotten these details on the live account. So this is the information about the live account. Another very useful Alpaca endpoint is the positions query. It's not at all unusual. You want to know what your holdings are, because at a certain time of the day you may want to sell those. So the positions query here sends an object, and it tells me that, and I sent the live account. It says you're holding 1 share of Apple. It gives me a current market value, cost basis, when I bought it, how much money I made on it. So I bought this a while ago. Unrealized P&L, et cetera, et cetera. All these are very useful statistics in terms of determining the success of your trades. If you want to trade options, you'll find that the options contract node is very useful. To get the option contracts, you'll need to provide a symbol, and then the date range, which in this case is greater than, I went out a year, almost a year, so you can see these later in the year. So this would be options that between the 5th of December this year and the 12th of December. And when I click this, you can see I got 100 contracts back. By the way, that's the limit. That's what Alpaca provides. And when you start building your trading apps, you'll find this. The Alpaca order node is very important. You need to precede the order with the information defining. You have to send an array with the values for that order. In this case, you can see I'm going to buy a share of Bitcoin, or rather a tenth of a share of Bitcoin. You can choose your type. This can be any of the various market types I put in market because I wanted to go through. You can also do this in extended trading. This actually isn't relevant for crypto because that does trade 24/7. And then all crypto time and forces is a GTC, good till canceled. So I'm going to click this. I defined an order. I also saved the trading ID for that particular order to a flow called trade ID. So let's just make sure we got that. So you can see the trade ID was stored. We store the trade ID because in the next flow we want to actually confirm whether the order went through. And we do that with the Alpaca query node. Here we pass the trade ID to Alpaca. And we get back confirmation on that trade. So you notice the trade went through, 1/10 of a share. Filled was 1/10, just as we expected. Okay. And so the order was received and handled. I'm going to go back for a moment to the Alpaca order to show you this error handling node, which is a function node, again, pre-written for you. But this is designed to tell you if there was an error in the order. Say I forgot that I needed GTC with crypto and I tried to pass a day order. I get back an error code. So the trade was rejected with a code, gives you the error code, and then this script also looks up the error code and tells you what it is. So see, it was an invalid crypto time and force, which is useful to know. So change this back to GTC. Now, the next thing I want to do is confirm that I actually, I bought that 1/10 of a share of Bitcoin. Let's see if I actually have it. I'm going to look for my positions in my paper account. I do get back an object, so there was an order that went through, and you can see here that this is interesting with crypto. This is how Alpaca extracts its fee. It doesn't fill the exact quantity it fills, but takes 25 thousandths of a percent, or rather 25 thousandths, 0.25% of the transaction as a fee. So it only fills a little smaller portion of what you ordered, and then it pockets the difference. That's how Alpaca pays itself. But this actually shows that the order went through, or not only did it go through, but it tells you what you bought. So that's also very useful to confirm what you have. And then finally, very similarly, in this case, I want to do an Alpaca sell order. I simply define the function key as a sell rather than as a market. The quantity is 0.9975. When I execute this then should have sold that position. If I check my positions, it should be 0, and it is. It's empty. So there's a glossary of useful notes. That's not all the notes in the package, but this is certainly a lot to get you started.